Okay, gang, we want to take a look at one other technique involving vector mathematics, which is known as vector subtraction. Okay, vector subtraction it's not hard, it's very easy, but you have to make sure you don't mess it up. Let's take a look at two vectors. Vector A will be a displacement vector of 5 meters pointing westward. Vector B will be a 4 meter vector at an angle of 30 degrees north of east. So that puts it in quadrant 1. We're interested in finding what we're going to call D. D for difference, meaning subtraction. Vector D, and it will equal vector A minus vector B. Now the way we do this head to tail is like this. You're going to, instead of subtracting, in order to subtract B, we're going to add what's known as the negative of vector B. Now what is the negative of a vector? It's a vector that's the same magnitude, but it points in the opposite direction. So we're still going to do head to tail vector addition, but now we're going to add a vector that's going to be 4 meters at 30 degrees, and this will be it'll be south of west. Let's take a look at it. Now we want to do this. First we're going to draw vector A, which is 5 meters west. We're going to start right here. We'll call this the origin. We'll call it point P for reference. We'll use a scale that 1 centimeter equals 1 meter. We'll draw a vector that's 5 centimeters long, headed west on our paper. It will look like so, 5 centimeters long. Okay, this is 5 meters west. This is vector A. Now we're going to add to this the negative of vector B, which means that it's going to be 4 meters long, but 30 degrees south of west. So it's still head to tail vector addition. So we're going to take our protractor, we're going to lay it down and find 30 degrees at the arrowhead of A. Line it up carefully on our graph paper. Find 30, put a dot with the protractor right there. Now we're going to shoot a vector down that line from that arrowhead. It's going to be 4 meters long. Drawing it from the tail of the first, pointing out from there. Okay, put the tail of the second at the head of the first, I should say. And we're going to make it 4. We're going to go from 1, 2, 3, 4. Okay, from 1 to 5, the way I'm using this protractor. Okay, here's our 4 centimeter vector, which is 4 meters. Double check that length. Looks pretty good. And there is the angle. That's west. This is 30 degrees. And it was 30 degrees south of west. Now we've subtracted, we've added the negative of B, head to tail, and then our resultant, actually it's not the resultant, it's the vector difference. It's a subtraction process, but we use the same technique, head to tail, like we would do when we add. The resultant, it's not the resultant, it's the difference. Okay, the difference here will be this arrow. Okay, and let's check out its length. We used a 1-to-1 scale. It looks like it's 8.7. Yeah, so we got a length here that's 8.7 centimeters, which it's just going to be meters. And then we have an angle here. There's theta D, if you like. the difference angle, we could call it. Let's measure it with our protractor. Line it up carefully at point P, the way we did when we first started drawing this problem. And we'll see that it looks like it's about a little glare there from the protractor on the screen. We don't know if that's not getting any better. It's a little better. We zoom in a little bit. You might see it a little better. It looks like our angle is about 13, almost 14 degrees. Okay, so we've got that the angle is 14 degrees, and that angle is south of west. So this is our vector difference, okay, which is A minus B. Now let's take a look at doing the following then. Let's look at, we'll call this difference 1. Let's call another one difference 2. And for this one, let's take vector B minus vector A. Now what does this mean? Well, it means that we're going to add the negative of vector A to vector B. So that's going to be B, vector B, plus the negative of vector A. And what's the negative of vector A? Well, as we said before, the negative of any vector is it's the same magnitude, but it points in the opposite direction. So we're going to do a 180 with vector A. It's going to be 5 meters towards the east. So let's draw this first. Let's come down a little bit on our paper. Scoot this up so you can see it a little bit better. And let's zoom us out slightly so we have a little bit better perspective. And let's start right about here. Point P, the start of everything. Call it an origin if you like. Let's draw vector B. We need an angle of 30 degrees north of east to do so. Put the protractor on the paper, use the graph paper, line things up. Find 30, put a dot at 30. And then draw an arrow that's 4 meters long. Well, it represents 4 meters long, coming out of point P, which will be 4 centimeters long. Okay, to be reasonably neat about our work. Okay, there's 4 meters. Well, represents 4 meters, I should say. And the angle here, as you can see, here's our 30-degree angle, and it's north of east. We're going to add, put the second vector we're going to add is going to be the negative of A. We're going to put the tail of that vector at the head of the first. We'll be going east this time because it's the negative of A, which was initially west. So we line our protractor up, use the lines on the graph grid, the grid of the graph paper, to orient ourselves for east. Go eastward, draw a 5 centimeter long vector heading east. Double check that length, make sure it's not too long. Looks decent. Okay, this is 5 meters east. This is negative A, the negative of vector A. This was vector B over here. Okay, let's look at what we've got. Again, it's the same process as head to tail addition, but we just add the negative of the vector. And we go back to the starting point, and we draw the vector difference from the tail of the first, pointing towards the head of the last one we drew, just like the resultant, same technique. Okay, and we draw this up to the arrows always meet. The arrow of what our answer will be meets the arrow of the last vector that we drew. And let's check out this length. The length is, it looks like it's 8.3. No, I'm sorry, let's try that again. I don't think that's correct. I think I've got 8.8 this time. Okay, so it's 8.8 meters. I think I made the 5 meter east vector just a hair long. So this is just a little bit long, but it's acceptable. It's an acceptable drawing because it's close. It's reasonably accurate. Let's find an angle. Now we're looking for an angle between our reference axis of east and the last arrow that we drew, and hopefully it's going to be something like what we got in the earlier problem. Looks like we're getting it's 10, 11, like 13 and a half, almost 14. Okay, so this is 14 degrees, and it's basically north of east. And this is difference 2. Earlier we figured out what we could call difference 1. Now let's take a look at these two. You might note that they both have the same, or very close to the same magnitude, 8.7 and then 8.8. They have the same angle, 14 degrees. 14 degrees. And the only thing that's different is they point in opposite directions. Okay, so what can we glean from this? What do we get out of this? Well, basically what we get is we can look at this and come back out a little bit, and we can see that the vector difference of B minus A, the one that we just finished, vector B minus vector A equals the negative of the vector difference of A, vector A minus vector B. And so what does this mean? Well, it means that they are the same magnitude, but they point in opposite directions. And so B minus A was 8.7 meters, 14 degrees south of west, and the negative of that is 8.7 or 8.8 meters, slight difference there, same angle, 14 degrees, but it's north of east in the opposite direction. So the vector difference B minus A equals the negative of the vector difference A minus B. They're the same magnitude, they point in opposite directions. So to sum this up, when you do vector subtraction with the graphical method, that's what we've done here, the graphical method, you add the negative of a vector, and to add the negative of a vector, you do a 180. Same magnitude, opposite direction. It's still the head-to-tail technique.